Okay, exercise 169, page 426, question 3. If we look at this question, you can see we have a function that describes the rate of change of angle with time as the wheel is rotating. Now, I've plotted the function down below on the autograph. We can see that this is a quadratic function. The 3t squared tells me that, so I'd expect that quadratic curve. I'd also expect the quadratic curve to go this way up with a maximum value because of the negative sign. And also, we can see that when t equals 0, theta has actually got a value. So if we look at the function here, when t equals 0, which is at this point, then we look at the up the y-axis, which is measuring the angle, we can see that we have a value around about 10 pi or 31 for the angle. So this is telling me that when time equals 0, this has started. It's at a particular point. It's got an angle theta at the start, rather than theta being 0. So that's what the curve looks like. And on the right-hand side, you can see a diagram showing this angular rotation of theta marked on a circle, and it's rotating anticlockwise, as we're familiar. So part A asks us to find the time when the wheel comes to rest. That's when the rate of change of angle with time, d theta by dt, equals 0. In other words, the angular velocity equals 0. So part A is asking us to differentiate and find out when this equals 0. So we have theta equals 10 pi plus 24t minus 4t squared. We need to differentiate. And theta by dt equals 10 pi disappears, constants disappear. 24, t disappears, minus 6t. And don't forget, this gives us omega. Angular velocity is the rate of change of time. So this is actually a function describing the angular velocity of the wheel. We're interested in when the wheel comes to rest. So 24 minus 6t equals 0, adding 6t to both sides. 24 equals 6t. Dividing both sides by 6, t equals 4 seconds. So the wheel comes to rest after 4 seconds. Looking at the rest of the question, part B, what is the angle turned to in the last second of movement? So what we need to do is find out what the angle is after 4 seconds and what the angle is after 3 seconds, and take one away from the other. So back to the original function, theta equals 10 pi. Plus 24t minus 3t squared. And when t equals 3 seconds and t equals 4 seconds is what we're interested in. So when t equals 3 seconds, substitute the value for t in. When t equals 4 seconds, substitute the value for t in and subtract them from the other. So theta equals 10 pi plus 24 times 3 minus 3 times 3 squared. Theta equals 10 pi plus 24 times 4 minus 3 times 4. And if you work that out, take one angle away from the other, then we should find the angle